Welcome to the next video. In this video, I want to show you shortly how you can profile your Python code. In the last video, I showed you how you can measure the execution time of your Python code. And now I'm here in the official standard library module, which is called cProfile. So cProfile and another module that is called Profile provide deterministic profiling of Python programs. A profile is a set of statistics that describes how often and for how long various parts of the program executed. These statistics can be formatted into reports via the pstats module. And I've prepared a little code for that. As a note here, the profiler modules are designed to provide an execution profile for a given program, not for benchmarking purposes. For that, there's a time limit for reasonably accurate results. This particularly applies to benchmarking Python code against C code. The profilers introduce overhead for Python code, but not for C-level functions, and so the C code would seem faster than any Python code. So this side note here just means this profiling here can be used to see what parts of your program do take more time than other parts of your program. It's not about evaluating how much time does every part of your program or your computation need. It's just a way to see what is the bottleneck of your program, for example. So I have prepared a little code here where we just carry out our vector addition for 100,000 times, for example. So it's just the same code as in the last video. And here I have prepared a little function that is called profile that uses this cProfile module from the standard library. Also, as pointed out in the documentation, I use here the pstats module that will create a pretty nice console output to us to see how much time did every step of our computation take. So if I run this code right now, it takes a moment, and now we would see, and let me make our terminal a bit bigger. So now we would see here that we had, let us see, 4,708,898 function calls that were executed in 1.362 seconds. And here is the most important part of our analysis here. We see how much calls of any function were made. Then we see the total time of this function calls. And next we would see here the summed up time of each computation step here, I would say. So at first, if I scroll up a bit to our code, I would see, okay, I just create a vector instance, or I create two vector instances, v1 and v2, with two random values from the random.randint method. Since we are creating here random values, the random function here, as we can see, the rand range function, for example, is called 400,000 times. Why 400,000 times? Okay, we have 100,000 times these computations here. Every vector takes two random values. We have two vectors, so in each iteration here, we draw 4 random values, 4 times 100,000. So we have 400,000 function calls to the rand range function that is called underlying in the randint function. Then we have a lot of more functions that are used or just called inside this random function here that is a module just from the standard library. So a lot of work that is done here under the hood. And we will see here, for example, we have 100,000 calls of our dunder add method from our vector.py file. As we can see here, it is defined in line 117. So you can see here exactly where the function call comes from, which is pretty handy. And with this little statistic here, you would just see, okay, this function is called for example, 400,000 times. This function is called 100,000 times. And now you can evaluate which of all of these function calls could be a bottleneck in my computation. And yeah, if a function is called more often, it might be a good idea to look into exactly this function that is called very, very often to maybe see, can I optimize this function a bit? You do not have to optimize all functions. So if a function is called only a few times and the function call just takes not much time, you do not have to worry about, and you do not have to optimize your functions. Since we are coding here in Python, optimizing functions is most times not the case anyway. So you just could use the statistics here that I showed you to just see what is the bottleneck of your code. For example, I would see 800,000 times the instance method here is called, which is probably due to the constructor, I guess. Yeah, in the constructor I have 2 calls of is instance, so we would have 4 calls in each iteration. And also in the dunder add method, I guess there I have also, well, let me check. Yeah, here again 2 is instance calls. So I would see here the function that is called the most is obviously here the built-ins.isInstance method. And if I now would see, okay, I don't need this function, for example, so I could remove it. So I would have removed at least the function that is called the most time. Oh, as we can see here in the column of the total time, it would take us to 0.146 seconds to execute these 800,000 times of the instance method, for example. So if we see we do not need this, we can drop this, and at least our execution time should drop a bit. As it is stated as a side note in the documentation, you shouldn't care too much about these total execution times, since this C profile or this profiling does add some overhead to your computation. So if you just want to measure the execution time, just use the timeit module from the last video. If you want to see how much each function here is called and to evaluate which function could be a bottleneck in your code, you can use these profiling tools that I have presented here. If you want to profile your own code, you can just copy this profile function here and you can use it in your own code to get this kind of overview here. But to be honest, the execution time measurement is a bit more important, I would say, for Python at least, than these profiling tools here. But I just wanted to show you that these exist in the standard library. And if you have any questions regarding this, you can contact me. Otherwise, we will see us in the next video. Bye bye.